So you went through these without a problem first.
First, two. Yeah,
Let's do it. Okay. After the switch has been closed, they asked first, that is, what is Q, the charge on the capacitor after a time of infinity? We found it to be approximately 125 microcoulombs, I suppose, yeah, microcoulombs. Microcoulombs, that is Q infinity. So now they want, the switch has been closed for a long time, it is open, this QT open. The charge on the capacitor at the time T opened, 671 after the switch was open. So they want, so now, at first, this was closed, right? And the capacitor is charging. After time, infinity, after a long time, the charge on the capacitor is 125 microcoulombs, right? After that, they opened the capacitor, they opened this circuit, so this no longer does anything, right? So we're only looking at this circuit, right? Because this is an open circuit, no current flows, so we're ignoring it, right? So it's no effect. So now the capacitor is discharging. Its maximum charge is 125 microcoulombs. Right? So what they basically did is they separated the times. At first there was a time T closed that ranged from 0 and then went all the way to infinity. Right? That's Q infinity, and Q0 is 0. And then when they opened it, it's like they reset the time. T open starts at T0 and also should range to infinity. And they're asking you at a time in between that, at T equals 671 microseconds. They want the charge there. Now after it's open, this is discharging, right? So the graph looks something like this, right? So that's Q, and this is time T. And you know the equation for the graph? That's Qt is equal to Q max, right? Times e to the negative t over tau. I believe that's right. These equations are derived with differential equations. You saw how they derived in the field.
No, I didn't look at the
In the pre-lecture. In the pre-lecture,
in the pre-lecture, yeah.
That's basically how they derive all these equations. Yeah. And they're pretty simple, right? It's here when I say differential class, it's like first order linear. All you have to do is find an integrating factor and end up with that equation.
So then tau is what? RC?
Tau is RC, yeah.
And
tau
R
is
is the total.
R?
Yeah.
R.
R would be.
Oh, R, yeah, R is the resistance. It's total
resistance. Just the resistance of the whole thing, or just those two?
The whole thing that's effective. The effective resistance here. This is not effective. This does nothing here. So only these two are doing something. That's 72 and 53. Let's see if this works. Can you see that for a second? Yeah. Okay, so the R equal 52 plus 72. 53 plus so 125. T RC would be the capacitance, so it would be 35 times 10 to the negative 6. Alright, so it would be Q max, which is 125 times 10 to the negative 6 times e to the negative 6. You want to open up a page in my Explorer so you can try to put in yours? If you want.
If it works, I can just put the equation. I can do it all. Should work.
Yeah. What's on here?
No, that was over.
Okay.
Is it a microvolts already? Divided by 10 to the negative 6.
So it'll be
To the positive second. 10 to the second. Either way, if you're ready, it'll tell you like what you get cards anyway. Should be good. There you go. Yeah.
Actually, this is not even, this is separable, it's not even linear. So, yeah, it's separable. I don't even, I mean, I don't know if you guys do care or not about how you come up with the equations. Yes. Are you taking differential equations? No. And which calc are you?
I'm in Calc 2.
Calc 2. It's also works with Calc 2. Calc 2 is... Did you come up to differential equations in Calc 2 or not? There's like 2 classes or something about differential equations in Calc 2, I think. Yeah. They don't ask you for deriving these equations, they just give it to you because differential equations is not a prerequisite for this course.
you got the number you need?
Yeah. 31. 31 and 3 should be. 31. Good.
What is IC max? The maximum current that flows through the capacitor switch is proposed. The positive value of current
After the switch has been closed?
Yeah.
Okay. When is the current maximum?
Current's maximum right away. Wait, hold on.
Wouldn't it be, yeah? Wouldn't it be when it's right away?
Let's see. So when right away, it's a wire. It actually depends on the situation when Imax is, but it doesn't depend on the situation when, in this case. So after the maximum current flowing through the capacitor or the circuit? Yes. So in this branch?
Capacitor.
Capacitor, okay, yeah, right away. Decreases, yeah.
So would it just be the number we just got divided by the voltage?
The number you just got for the charge on the capacitor?
Yeah.
Why?
Wait, no.
It needs to be something with R, with the V equals IR, right?
E equals IR, right? You can do that.
Yeah,
you can
ways.
You can do that. There are other ways. I mean, you can take the voltage from here to here. You know what the voltage of this is going to be. Actually, V equals IR is the simplest. Basically, yeah. Because you know, the second the circuit closes is the capacitor is basically a wire, right?
Mm-hmm.
So you can replace this entire circuit by your resistor, your resistor, your resistor. You're trying to find this current. Right? And you know the values of the resistors. That's 53 and 16.
So if you know the voltage drop between, like that middle, yeah, if you know the voltage drop there, then
That's a voltage drop between here to here, right? And then you can find the current to that.
and the current of that will be the same as the current of
Yeah, because
capacitor,
they're in
right?
series, yeah.
Okay.
So, wait.
The problem is you can't tell if you're right away. Do you remember your voltage drop?
No.
No. You would have to redo it.
Uh-huh.
Yeah, you have to redo it.
Wait, so I added up the resistance. Because the capacitor is throwing me off. Actually, no, those
Just
would
open
be,
it to wire so you don't.
At first, the capacitor has no voltage. At first.
Okay,
because it
so
has no
that
charge.
makes,
So you can't use capacitors.
so it,
So you have to use R1, R3, and R4 to get the R total. And then you have to divide the voltage. Oh, voltage divided by resistance to get the current. And then once you get that current, you just find each voltage drop, right?
Yeah, basically. You can do it voltage division. But I mean, that's basically voltage division. These are just like circuit shortcuts that you can do if you're comfortable with circuits. If not, then do it the long way. I mean, if your major is not related to circuits, you don't really have to learn these tricks. You just do it the long way because you're not going to see a lot of circuits in your life.
conversion has plus 53 plus 50. Right?
Did you just do R1, R3, and R4?
No, and I2. I mean R2.
There's no voltage going through here. How is this gonna work?
So it's
It's just R1, R3, and R4.
So that is 242. Voltage is 12.
So 12 divided by that answer. And I just find the voltage drop for each one. And just find out the bottom one too.
On this one?
Yeah.
So it'd be,
The current times that resistance.
so it'd be this.
The current, so the 0.05 times. Oh wait, is R4 the same as R1?
No.
Oh, so you got.
2.0.
Oh.
I forgot about that last resistor, sorry. Yeah, I noticed that you.
So this would be 5, 0, right? So across that, we put 2 7 minus. Yeah, that's 2 7.
The voltage drop in between here. So now that you know the voltage drop between here, you can use it to find the current once the capacitor opens, right? No, not the capacitor, once the switch is open.
Don't you want the current while it's closed though? Isn't that what they're asking for?
Yeah, it's closed.
Yeah, so just.
Oh, yeah, so when you're closing it,
So right now you're only looking at this circuit. Because you already said that the maximum current flowing through the capacitor is going to be the second it's closed. And the second it's closed, this is what you have. This switch is closed, that's connected. This capacitor is basically a wire, so it's just a wire. You have two resistors in parallel with these resistors. Two resistors in parallel and then series with those two resistors. And all you have to do is find this current. And the first question asks you to find this current, right? Right? So from that, you can find voltage drop here and here from that current, because you know that the current flowing through I4, through R4, which is I4, is the same as the current flowing here. It's only going to be different here. It's going to branch on the here and here.
Wait, so are we including the resistor by the capacitor?
Yeah, why wouldn't we?
Internal resistance? Yeah.
Why wouldn't we?
So it's not.
Why wouldn't we?
because it's no voltage going through the capacitor.
No voltage across the capacitor. What does that mean?
Like
a
you
wire.
said, it's just a like a wire.
It's a wire. It's not
So
an
you
open
have to,
circuit.
so you have to include it.
Yeah, there's current.
Okay.
There's no voltage across it, but there's current.
Alright, so it'd be the inverter.
There's no voltage across a wire,
Okay.
but when it's connected to a battery, current flows. Right?
Mm-hmm.
If you have a resistor here, there's no voltage from here to here, but the current still flows. It's a wire.
Okay. Just because when I think of like when you say no voltage, I like think of the equation and then say if there's no voltage, there can't be a current. That's how I think about it. But that's not right then.
Because of which equation? V
Like V equals IR. If there's no voltage there, then if it's zero voltage, then there's zero current. But that's wrong, right?
This is 0. I or R must be 0.
Oh.
Wire has 0 resistance. So that's 0.
Oh.
We don't know nothing about the current.
So that doesn't mean exactly that I is 0.
Mhm.
Okay.
But
Okay, that makes
if
sense.
V equals IR across a resistor and V is 0 across a resistor, if this voltage is 0, we know that the resistance is not 0. We know it has value, so this can't be 0. That means 0 is equal to R times 0. That means I is 0.
Now it makes sense.
Right?
Now it makes sense.
So I have the total resistance, I have the current through there. And it was. I have the total resistance and I have the current through that middle resistor.
The current?
Middle junction.
No voltage drop and you give V equals I.
So
And you know the resistance of 53, so. Or your I, R, whatever that is.
then it's just this.
I don't believe it's that. I'm not even doing such thing. It's fine. As it's a second.
Now it's asking what is the IC max open, the maximum.
What is IC max open? The maximum current that flows through the capacitor after the switch is being reopened.
No, it's just looking at that little portion, right?
Yep. That's fine.
So
What is the current maximum?
would the voltage drop be the same or no?
With the what?
The voltage drop wouldn't be the same, would it?
Across what?
This middle portion, because it's the cap.
Not necessarily. When would the current be maximum? At what time?
First.
At first.
Yeah,
Right? Why?
because then it would start discharging.
It starts discharging, right? So when the charge is maximum, that means the voltage is maximum, so the current is maximum, right?
Okay. So if we want, maximum current, I guess, I need to find the voltage and,
Can you repeat what you said?
So when is the current maximum? When this is opened?
Yeah, right when it's closed.
Right when it's closed, right? Because why? Because that's when the charge is maximum, right? Like we said 5 minutes ago. That's when the charge is maximum. And C equals Q over V, V equals Q over C for the capacitor, right? That's when the charge is maximum, that means the voltage is maximum. So that's when the maximum current goes. Maximum voltage minus maximum current.
see, we have the,
When it's open. Okay.
oh, the maximum charge.
You know the
We need
maximum
voltage. Oh, wait, it's Q equals CV, right?
Right.
So if I want voltage divided by Q. I'd use the solution we got from 3 then, right?
No, that's not at T equals 0. That's at T equals 671.
Just find it. Here, got that.
What about this though?
Oh, that would be our charge.
That would be the same, wouldn't it?
Yeah.
It would.
This is
C equals QV, right? Is it CV
Hold on,
equals Q? CV equals Q?
So,
Q equals CV.
No, now it's just open and it calculates
I'm in Firefox. Yeah, still. There is.
What about the capacitance? Alright, so that's my voltage. So we need to do that divided by the 1.5. That seems like a lot. That seems like way too much.
What are you dividing by? 125?
Yeah, your capacitor is in microfarads. Which is that? Yes, okay. That is a lot for current. Oh, wow. So, your charge is in microfarads.
So what is?
Charge. So that's,
Oh.
so just take the E96 off.
Syntax. Okay, so that's my charge. So it would be what's my voltage?
So the Q from
So it'd be negative because it's going to go 12 amps there.
Because when we're charging, this is positive, right? So positive, 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 positive. It's positive.
So as soon as that gets open, that part pretty much
That's
gets
gone. This is still
And
positive.
then it flows in the opposite direction. Okay.
Because we're assuming that the positive charge flows from the battery, so all the positive charge accumulates here and sends the positive charge away from here, so only negative charge is left here. Right?
Mhm.
That's how capacitors charge. Throwing positive charges here, positive, and then we have neutral here. As positive comes here, pushes the positive charge away. So that's left with negative charge.
Yep. So it'd be negative.
The what? The difference.
see.
No. No, well, this is.
Okay. Same logic applied to like a capacitor in the car. Shit. That's all. Yeah, what's on the battery? So when the capacitor isn't full, it acts as a wire, correct?
When it's
Not when it's charged.
when it's charging
It acts as a wire.
at the beginning, yeah. Then it starts to act like a wire voltage. Then it's basically like a capacitor. Then the current starts increasing slowly because charge is accumulating on it. So it actually has voltage.
Okay.
So it actually has an impedance. We'll talk about impedance later. Impedance is basically, impedance is like the bigger concept of resistance. Impedance is how much something
So it's pretty much like
pushes away, yeah, it pushes current in the opposite direction. It's how much something impedes.
And doesn't impedance fluctuate with frequency or something like that?
Yes, that's an AC circuit.
DC, this
Basically-
car would be a DC circuit, right?
A car,
Yeah.
because it runs on battery.
Yeah, it'd be off of, no, that'd be equal voltage, so that'd be DC, right?
Right.
Right.
And impedances have to fluctuate. Like if it's an AC circuit, then impedance does fluctuate. But I don't know what the purpose of this capacitor is, honestly.
It's
know what it does?
for, when you have a lot of power going to the cell, it gives the amp the
Right.
power it needs.
Because the capacitor discharges really fast, unlike a battery. A battery can't have
Yeah.
a discharge rate as fast as a capacitor. That's why they charge a capacitor for it. I assume.
Yeah. Now I know. Now I know why I make myself very hard, not just that.
Do you know how they make those capacitors? Once, I mean, so we always say capacitors are two plates or whatever, but I mean, all circuits, electronic circuits, if you look at them, the capacitor is actually something like this, right?
Mhm.
That's basically a capacitor. Do you know how to make them?
Not exactly sure. Is
So-
it like rods inside of it?
Not
Some
exactly.
kind of like.
So they have to be plates. The bigger, since C is equal to epsilon naught A over T, right?
Mhm.
D, sorry. And we want maximum capacitance. That means we want a really, really big area, but a really small distance, right? And to do that, what they do is they get, and there's also a key, the electric constant. So they get a sheet, a really big, small sheet, but big width. So use this. And they put the dielectric material here, and then they put another sheet here. So it's basically like a sandwich, two sheets and dielectric in between, and they roll it up. Right? So actually, so this is connected to one wire, and the other is connected to the the other wire. And these sheets aren't actually touching each other. Dielectric
Because
is
of
in between.
dielectric.
Yeah. And so they roll it off. That's a
The
really big
capacitor I
area.
have now is, it's probably as tall as this, but like that thick.
I assume that's how it's made. I'm not
That-
sure if
that
all
makes sense.
capacitors are like that, but as far as I know, a lot of capacitors aren't like that. They're
Cause I
basically
know some of the
sheets.
capacitors, like the one I was looking, the new one I was looking to get, it's like $300 for, how many farad is it?
You said one for it. No, three for it.
Three. For a 3 farad capacitor. Yeah. So with the dielectric in that, be like great.
I assume that's a big capacitor.
What's the equivalent?
Why are you trying to get that?
Why?
He wants to make the car look
Still my subs hit hard as hell.
You sure it's not good for them?
The subs? The cap won't. If anything, the amp will, because the cap feeds into the amp.
It's a lot, right?
That's a lot. What's up?
Could be a person. Yeah.
Have people done that before?
Okay, so
Yeah, right?
capacitors?
Yeah, like, no, not that capacitor, but like that, that was thirds, right? People done that before.
The region space containing uniform magnetic field, and whatever they say it's a magnetic field. What is it? B. What is the time T required? Reimmersion. That's where it's going.
See, some people do.
How big is the capacitor though? Is it the same big as yours?
Is
It's a proton.
that's Q. Speed V. So now getting fields going upward, right? So right hand
See,
rule.
they wear it.
This is close. Positive charge.
Is that how you have it?
Points in that direction.
I don't have my shit in it. I still gotta get it.
Points in that.
Cause I got
So
some cars.
the force is going to be, when it's
Take a
here,
picture
the
of
force
it,
is
yeah.
going to be in that direction, half,
The
right?
car. You just take a picture of it? Oh, no, it's because you have an
At
actual
any
model,
moment, the
have you?
force is
No,
going to be
I-
pointing that way.
Let me see.
Right now I'm driving a Benzo, son.
You're not gonna put anything on the Benz, man.
And it's
Benz is
obviously
stop, man.
going to come out at also, right? So it went in the right angle, right? As long as
There's
it's
a picture.
right?
There's a picture.
And what's the radius?
I answered already, so
They didn't give you any.
From the equation, what's the equation for the radius again?
Oh, you need radius.
Remember the centrifugal force? Centrifugal force. Derive it. Derive it. Centrifugal force.
Yeah.
Remember it?
No.
Centrifugal force is, so force is m times a, right?
Yeah.
So m times a, which is centrifugal acceleration,
Watch this video.
equal to the magnetic force, B, and C. Because they're quotient, the centrifugal force here is the magnetic, it's the one that's pointing inward and keeping it at velocity this much. So F of B equal to QVB, right?
Yeah.
That's just for the driving equation, because I honestly don't remember it. So that's R is equal to M squared over QVB. So R is equal to MD squared over QB. So that's the right answer?
Yeah. Yeah, it is right.
Is it right?
Yeah.
Yes. And be over QB, right? R is going to be over QB. So that's a radius, right? You know that that's the radius here. All right. And you want time.
Yeah.
What's something that relates time
It's number
to
something.
any of the variables we have here?
Velocity. Basically,
Oh, it's two.
yeah, I just need to find out the arc length divided by this.
So V is going to be equal to S, which is the arc length, over T, right?
Yeah.
That means T is equal to.
Damn,
That's what
10 farad.
all you need to do is
There's no
find out.
gap, dude. Oh shit. That's ridiculous. 10 farad.
He's really obsessed with doing that. Yeah, not just the capacitor, it's just the sound. He wants the music quality of his car to be like the best.
I want it to be a studio as I drive. Good. I can see this sexiness.
So they don't just sell cars, they sell the whole amps too.
What question?
Yeah.
This is just for like sound shit.
Goes from low price to high price.
Mm-hmm.
How much does it cost?
What?
Which piece that you're trying to get?
It's just for the amp.
1,500 watts.
That's RMS. That's not peak either. And peak, I think it can push out to like 3.
3,000
Yeah.
watts?
That's peak. 1900.
Yeah, it shakes. He used to have another car. He did this stuff for his other car. And he sold it already.
That was only 200.
Yeah. He was.
I'm gonna be
It was like
fucking-
you're in the car and it shakes. It's like you're getting massaged. Yeah, it's crazy. He wants more. It's already pretty loud. It's
I don't know what this car's gonna come with. Cause some of them come with the Bose system in them.
But you're gonna take it out anyway. You put your system.
The Bose that comes with, I don't think it comes with a sub though. I know my mom's car comes with a sub in it already. It's got an amp in the back too.
How long do you stay at this session?
Usually it's late, but I mean, no officially it's late. Usually it's late.
Break and shit.
Yeah.
I wish this car had a roll start. Like, it'd be warm when I got it.
What year is yours in? It should have it.
It doesn't.
I didn't. My Nissan, the 07 Nissan.
Has a Murano?
Yeah.
I'm pretty sure it doesn't.
It has like the when you does it unlock itself when you get close to it? When you're 5 feet away from it, the car just automatically unlocks. That's kind of dangerous, but
Yeah.
but once it like someone tries to steal it and you have that lock thing, it'll just turn off. Like if you're like 10 feet out away already driving away, the car just turn off.
Yeah.
You need to have the little
key
chip
in.
with it. Yeah, you need to have the chip with it.
Kidding.
You don't have a key anymore. It's push to start.
It doesn't have an automatic start function on it.
It's probably like
Still, so what is it?
I mean, they don't like you can get different colors for different functions.
I'm pretty sure they would have told us that when we bought the car.
Yeah, it's probably additives. Like I bought it used, they didn't buy it.
Oh yeah, they probably added
Yeah.
that shit to this.
Except for music.
It has like the whole reverse, the backup thing, and
The camera?
the camera to back up. Yeah,
That would have it on there.
I hate that thing. No, it's just the size. Isn't that the size? Oh yeah, hit things in the back. Look at that mirror. Are you supposed to leave right now? The long one?
With mine, it's Alright, thanks man.
Thank you, babe. See you tomorrow.
Have a good night.
Do you need that? Oh, in the class you mentioned there's two different right?
One for
Yeah.
one for positive.
But
one
then
for
there is
negative.
no. But there is two. One is like use this.
Oh yeah, the method.
And then there's one is this. But then there is one that is general. The other one. This one is not.
They both work ever. Depends on whatever you like. There's actually like 3 more.
Can you tell me how exactly to use this? I'm a little bit confused actually.
A. That's A. So it's A cross B.
Okay.
Right hand drill is
No,
on.
but I want to know which this finger represents what unit.
No, it's not. It's not a unit or something.
No, I mean it's like the B field or the.
Right.
Correct.
But I mean, this is the general thing about it. So let me just. So we have A cross B is equal to C, right?
Yeah.
And let's say this is the x-axis. This is the y-axis. Actually, let's not call them axes because that's something else. Well, it is not
it's
something
just
else, but
use
it's
A, B, C.
yeah. This is A, and this is B, and this is A. Right? This is pointing outward.
Yeah, yeah.
Right? It's always going to be A cross B is equal to C. A cross B equal to C. That's in direction. So if you use the first right hand rule, the one with curling fingers or whatever, A is pointing that way, right? And you want to move.
No, since both of it is general, I just don't tell me the other.
Okay.
It's confused.
A, B, C. A, B, C. A cross B is equal to C. A pointing outward.
Yeah.
B pointing that way. C
Okay.
pointing outward.
Yeah. Can you just make a magnetic field question?
F is equal to Q. No. Cross B. This is a cross. X cross. QB cross B.
So basically, the QB is A, and then B is B, and F is C.
Q has no direction, so it's just a scalar multiple of B. So one of them that way.
So this.
So if you have a B,
Yeah.
F, so T.
And then if it's a charge, if an electron, then
It's the reverse of this.
so it's just
VB, if VBF gives you that, then you go that way. Or you can use the left hand. The left hand gives you the
Oh,
same
yeah.
result.
Okay, yeah, basically, yeah, left or
Right there.
yeah.
Turn this off.